Hello everybody. In this video I will talk about confidence intervals for population proportion, and I will also discuss problems where I'm asked to find sample size. Okay, so a little bit of notation. So P is the population proportion in a specified category. This is a parameter that we usually do not know, and what we're trying to accomplish is to estimate P with P hat, sample proportion of individuals in the specified category, and give it a wider range than just 1 point estimate. Okay, so this is very similar to confidence interval for population mean. Okay, we will also have N, the sample size that's usual, and X is the number of individuals in this specified category. Now, we have conditions that need to be satisfied. Simple random sample. Okay, the population is at least 20 times as big as the sample itself, and then the items in population are divided into two categories. So for example, if I am interested in the proportion of students at FCC that speak a foreign language, then what are my categories? Bilingual students and those that are not bilingual, right? And then the sample must contain at least 10 individuals in each category. So if I were to compute a confidence interval by hand, what would I do? I would take my sample proportion and add E to it. Okay, and this is similar to what we've done for confidence interval population mean. We have a critical value with the alpha over 2, and this is equivalent to saying, let's go ahead and take standard deviation divided by square root of n. Okay, very similar to what we've done before for population mean. So we would do P hat plus E on the right, that's your upper bound, and P hat minus E on the left, that's your lower bound. But we're actually not going to do this by hand. We're going to use a calculator to do this. Okay, so let's go ahead and take a look at this problem here. Okay, what do we have? We have a sleep apnea problem. Sleep apnea is a disorder in which there are pauses in breathing during sleep, and people with this condition must wake up frequently to breathe. So let's say we have a sample of 427 people that are age 65 and over, and out of those 104 suffer from this disorder. So the first one says find a point estimate for the population proportion of those aged 65 and over who have sleep apnea. Okay, so what am I asked here to do? I'm asked to find an estimate, an approximate proportion based on my sample. So all I have to do is do this: 104 divide by 427. Okay, so what can I say? That approximately 24.35% of people age 65 and older, that's the proportion of people that suffer from this disorder. Okay, not exactly a small number. All right, so then how do I construct a 99% confidence interval for the proportion of those people, all people, not just sample people, of age 65 and over who have this disorder? So I would go to stat test, and the command that I will be using is called one proportion z interval. So if you scroll down here, we'll find it right here. One proportion z interval. At some point we will also be using two proportion z interval when we have two samples. Well, right here we only have one sample. Oh, okay, so let me go back there. Test one proportion z interval. Enter. Okay, what is x? X is the number of people in that specified category from the sample, so that's 104. What is the sample size? Sample size is 427. Okay, confidence level, we have 99, so that's good. We compute this, and what do we get? Okay, we get 0.19 to about 0.2297. Okay, so if you were to write it as percentages, that would be about 19% to 29.7%. Alright, so that's how we compute it. Just like before, we need to write an interpretation. I would say the following. We are 99% confident that the interval from 19 to 29.7% actually contains the proportion of all people age 65 and over who suffer from sleep apnea. Okay, so when you guys are writing interpretation of your confidence interval, you want to make sure that that sentence is in the context of the problem. So if a student or just a person outside of class were to read this statement, he or she would understand what you're talking about. Okay, so again, what would I write? We are 99% confident that the interval from 19% to 29.7% contains the actual proportion of people 65 years old and older who have sleep apnea. Okay, so that's how you would do confidence interval for population proportion on a calculator. Okay, so what is the only other thing that we need to discuss? What if we're asked to compute the sample size needed if we're given conditions? Okay, so to determine how large of a sample size you need, these are the following formulas that you will need to use. If you're using it for population mean, what do you need to do? You need to have your critical value. Now this one you will need to know, and that depends on the confidence level. Okay, then sigma, that's going to be given to you. Okay, and also margin of error, that's also given to you. So then what's the rule of thumb? Once you guys compute this number right here, whatever the number is, if it has a decimal part, round it up. Okay, so the rule of thumb is rounding it up every time, even if the decimal part is 0.03, for example. Okay, so if it's for population proportion, then we have two formulas. If your p hat is given to you, then we do p hat times 1 minus p, and then over here we have z of alpha over 2 divided by e quantity squared. Now if it's not given to you p hat, then p hat is assumed to be 0.5. Then this would be 0.5 times 0.5, and that's where that 0.25 comes in. Okay, if p hat is not given, assume p hat is 1/2, and that will give you this value right here, 0.25. Okay, so let's go ahead and look at a problem and see what we can do about it. A sociologist wants to construct a 95% confidence interval for the proportion of children aged 5-11 living in New York who own a cell phone. Okay, so we have a survey report that says nationwide the proportion is 0.2, so about 20%. Using this estimate, what sample size is needed so that the confidence interval will have a margin of error of 0.02? Okay, so this is a proportion problem. So I gotta use one of these formulas. Now I'm gonna use the first formula here, this one. Why is that? Because I know what my p hat is. It's 0.2. Okay, so how would I plug this in into my calculator? So it would be 0.2 times 1 minus 0.2, which is actually 0.8, so you don't have to compute it like that. You can plug in 0.8 times, I'm going to open parentheses here. Now the z value for confidence level 95%, that would be 1.96, and it's in one of those slides in this video. Then divide by what? Margin of error is 0.02 quantity squared. Okay? We get this value right here. What does that mean? Okay, so if this sociologist wanted to satisfy these conditions, 95% confidence interval, with margin of error being 0.02, he or she needs to sample 1,537 children. Okay, 1537, this decimal part right here, 0.64, tells you gotta round it up. All right, so that's how many children he needs to survey. Okay, what is the sample size if we do not have the estimate of p? What if we don't have p hat? Then you just use 0.5 times 0.5, right? So that's where your 0.25 comes in from. Okay, and then 1.96 divided by 0.02 squared. Okay, 2401. In this case, we actually get a whole number, so we don't need to round. So in this case, this sociologist needs to survey 2,401 people, okay, to satisfy these conditions. And that's how you would use this formula to compute the sample size needed with specified conditions. Okay? All right. Thank you for watching.